To dashboard debugging and performance. Performance didn't really fit on the slide anymore, but I think everyone knows that term. So what are the two big problems or the two big frustrations? One that we hear frequently is my graphs are not loading, which is pretty general, which is always a bit also a source of frustration for us because we don't really know how to respond to this. And I guess one of the goals of the talk is to also give you the tools to be a bit more precise and help yourself also in troubleshooting dashboards and also in being able to give us better error reports. And then there's a second one that's also popular. It's my graphs are too slow. And another goal of the talk is to give you also some hints on how to debug those kinds of issues and also to determine if Grafana is the source of the problem or the network or your data source. So the two big indicators here on that there may be a problem is either the spinner that you're going to see in the top right. It's sort of subtle, but if that thing's there and you're not seeing what you're seeing, it's because obviously you're waiting on something that's not there yet, right? That's the whole point. I should have mentioned, I'm director of user experience. So for me, it's always a bit a challenge to hear that this thing is not really visible, but at the same time, we don't want it to be all over your, in your face, because in let's say nicely designed dashboards, you shouldn't have to wait that long anyway. And then the second indicator is on the top left, which is when you have bigger problems, when basically queries are not returning anything. So let's debug some of these broken panels. I'm going to jump to Grafana. And let's start with this one. So if we don't even see a grid, it's pretty clear that a lot of things aren't going well here. And luckily, we're already telling you what's broken here. The data source Prometheus broken was not found. OK, that's good. I guess the fix there is to jump into the panel settings here and change it to the correct data source. The recommendation is to first look at which data sources are there, because it could have been that someone renamed the data source and didn't update the panel definitions. And I've got a couple here. None of them are called Prometheus broken. So I can at least have an idea now on which ones are there. So I can go back and edit this panel. And look at this. It shows a default one. That's definitely not Prometheus. Let's just use this one. That worked. OK. And there wasn't even a query in there. All right, there's one now. So we can consider this one fixed. Let's look at another one. This one. All right, at least we see a grid. That's good. This means there's something in there. We see a request error. We can look into the query inspector, for example. And we're stuck. OK, it's not loading anything. This is sort of sad. Maybe that's an issue for us to make better, that at this point you're sort of stuck, you don't get any feedback. My recommendation there then is to look into the browser development tools, and which you can, depends on your browser, but I just used the shortcut. So let's look at the network tab and see what happens. Currently there's no request there, that's good. So let's just try another one here. So there was a query range request, and it responded with 404. OK. There's an alternative, or at least this gives me an indication that something with the paths is not right. This sort of tells me where it's trying to load the data from. The problem here is that we proxy the request, so everything after the proxy prefix here, like everything, this part here, is what's being forwarded, and this actually looks correct still. So this is a valid subpath for Prometheus. So something else must be wrong, right? Where I would look now is the data sources themselves, and for this particular one, it was this one. And can anyone spot the error? Another thing here I can do is test. I still here I get the error for not found. So something must be wrong with this URL. Any hints? Say again? Oh, it should just be this. Yeah. Cool, that worked. Everything green, that's good. So we can go back to this particular one, and lo and behold, this worked. Cool, we're getting up. So that was one. Then here's another interesting one. We have another exclamation point here, and we have a parser error. Demo in label matching expected string. So let's look here. Let's go into the edit mode, look into the query inspector, because we probably should be seeing something. Let's load the query inspector. Also, nothing's coming up. Oh, that's a shame. This is where I go back to the development tools again. So let's do this. So let's look at this request. There seems to be down here. This thing helps. You can see the query decoded already, or like not URL encoded. And anyone spotting what's wrong? Say again? The quotes. Yep, quotes are missing. Correct. So we can fix that one here. Whoop. And run this. Yep. Oh, and suddenly we also see more in the query inspector. So that's nice. So it was a bit unfortunate that for some of the errors, the query inspector wasn't really helpful. But where it's helpful is to look at the results. Basically, if you're sure that the query is correct and everything, and you're getting something back, but it's like the data shape is not correct or anything like this. This really helps in figuring out what the raw data is, the underlying data that's being used to draw this graph. Okay, so let's collapse this again. So that worked. Let's save this. So do I have one more? No, that was already fixed. All right, let's go back to the rest. So that was this. Yeah, so just to recap, we were using, to debug this stuff, we used the data source's own settings page. And basically, unless you see a green label there, there's really no point in clicking further or giving us basically error reports regarding any panels, because at this point you're just not getting anything useful from the database, from the data source. One thing to note there is that various data sources have differently implemented test functions, and sometimes it's kind of helpful to look at the source code, which is in the Grafana repo, to figure out what they're actually doing. Because also the the data sources themselves develop independently. Like Elastic is releasing new things, Influx is bringing out new releases, and the way we test them may not be accurate anymore. So in that sense, we would also rely, or we definitely rely on your feedback there as well to find these things as quickly as possible. So let's continue. We've used the query inspector on the queries that have actually returned something. And when it didn't work, we were using the developer tools of your browser. So let's get to the point where graphs are slow. Anyone here having slow graphs? I would have hoped. Yeah. Okay. What? That's it? All right. All right. Let's quickly talk about latency. What makes a graph rendering slow? The mental model we have here is that once you click refresh, there's some time passing, and then you want to see the result rendered, right? And so it's kind of interesting to kind of explore what this means in terms of what needs to happen, how the data is flowing, how the request is flowing, because you probably just think that that normally you just directly request the Prometheus data source, for example, on a Prometheus dashboard. But by default now we have server access enabled, which means that there's actually the Grafana server sitting in between. So a request to a Prometheus from a Prometheus panel goes to the Grafana server first and is then forwarded. Anyone have an idea on why we make server default now? Yeah, so this is to support alerting, right? Because if you have browser access, this means that you would have to have a browser running at all times to have queries continuously done. So that's why we made server default now. And this means that there's something in between now, right? And now it's difficult, or now this can be another source of lag based on based on how your network is. And so let's quickly debug, or like give you also tools to debug this a bit. Let's quickly go to Explorer. So I've got a local Prometheus running that I've pointed at my local Grafana. And Grafana is also exposing Prometheus metrics here. So I can actually use this metrics explorer here to have a look at the metrics that are exposed. And there is already one here, which is data proxy request, right? This is what is this? These are summaries, right? So if I click here, I get the 99th percentile, and these are milliseconds. Okay, so this means that for like this region here, 99% of requests or of proxied requests went faster than 40 seconds, which is a really long time. Let's try the 90th percentile. Still quite a bit. Okay. Yeah. Anyway, so this helps you in figuring out how long the request took, basically from the Grafana proxy to the data source and back. Yeah. So to service the whole request. Right, and then on the data source, you might, like, let's say Prometheus itself, you would have similar metrics. So, for example, Prometheus. Usually it's like Prometheus HTTP. Not response size bucket, but response. request duration. Seconds bucket. Yep. That's a proper histogram, so we can do this thing. Let's look at the 90th percentile again. So, and then, because now this is measured in seconds, it's probably a good idea to convert this to milliseconds. So 94 milliseconds. Okay. Well, this is really fast, right? But on bigger systems, you would get much higher latencies. And this also gives you an idea on how much time your data source itself is taking, for example, to return data. But the problem still remains that that sort of in your mental model you're always just looking at the dashboard, and you know that the request was just issued, and then there's a spinner, and you're waiting for someone to come back, right? So another misconception is that the rendering takes a really long time, and for this you can basically use also these network tools here. So I made a bigger dashboard. Let's quickly go there. Oh, hold on. There's another one. If you have, or I don't know, who here has heard of Trickster already? So this is a way to also speed up the requests, where basically where Trickster is a smarter reverse proxy cache that you can put in between your Grafana and your Prometheus, which basically, if you have constantly refreshing dashboards, the request is modified by the proxy to only request the smaller time chunk that's not already there, and you can shave a bit of time and I guess also capacity of the request. So that's a useful thing to look at. Then I've done a couple of test runs earlier on a really big dashboard, and to also get a bit of like an intuition on where things are being throttled. And I also looked at the code, which was also new to me. But basically, when you start refreshing, what's going to happen first is that there's going to be an annotation query running. So this is something that can slow you down if you have very expensive annotation queries. And then a single panel would run all the queries in parallel. And then before it renders, it would wait for the annotation query and the target queries to return, right? So then the lesson there is, if your annotations are expensive, then you're going to have a longer waiting time to see results rendered, right? And the second lesson is, if you want to like disentangle queries and get faster results on some over others, then it makes sense to split queries over separate panels, because then they don't wait for each other. And then we ran some more analysis on which tweaks would help you get more performant dashboards, and we found that changing the time range to a shorter range actually doesn't help that much, even though you have to kind of request a wider range. Usually the data source is doing some sort of downsampling or the front end, and then so just choosing a shorter time range isn't really helpful there. Obviously, this breaks down if you're looking at a year as opposed to, I don't know, the last 3 hours. But if you had to like choose between 3 hours and 6 hours, it probably makes a little difference. Tweaks with more impact. Query limits that reduce the number of time series can be helpful, mostly because for every time series that's being returned, in case you show the legend items, those are quite expensive to render. But the graphs themselves, or like the lines themselves, that's not very expensive. And then the biggest tweak to a really laggy dashboard that you can do is currently to hide the legend items. So we ran some tests earlier on dashboards that have around 500 to 1,000 time series, and just by virtue of hiding the legends on all the panels, we got I don't know, like a 5x up to 10x improvement on render times. And the reason why this shouldn't be that big of an issue for you is that what's still enabled is hover, right? So you can still hover over the charts to get basically a direct mapping to color and to color of line and which time series it relates to. And that's all I have for now. Yeah. Any questions? Yep. Were you what is slow? So the question was if switching between dashboards can somehow be sped up, right? That was yeah. So yeah, we don't have anything like this in place. While I was doing test runs for this on dashboards with just a lot of time series on them, I thought it would be a really good idea to have this, just because every time you do a slight modification or you change the view slightly, it may trigger a whole refresh, and this causes like an immediate lag, and then this slows down scrolling and everything. And another solution instead of caching would be for us probably just not to refresh so aggressively on every change and have this sort of debounced. Yeah, but yeah. I mean, the preparation of this talk gave me already lots of interesting ideas on, speeding things up. Yeah, more questions? Yeah, so I guess, so just to give you a bit more background why the legend is expensive, the graph itself is rendered on canvas, so there it's a single HTML element, and it doesn't matter how much lines we put on this. But the legend items are HTML elements, and the more you add there to the browser, the slower everything becomes, and the more you move around and hover elements are triggering, there's browser reflows. So the conclusion there is. The more elements we have to print, like actual HTML elements, the more lag we introduce, and that's the problem. There's a couple of other things you can do, which is make a lot more use of template variables to basically reduce or to basically filter the queries based on some values that you've selected at the top. This will give you basically, or in the best, or in like a really good case, give you like logarithmical advantages on performance. Yeah, just by divide and conquer. Yeah. Okay. So there's a question by Matt Simmons. I don't use Prometheus outside of Kubernetes, so I'm ignorant of this. But is there any way the query interface could feature a PromQL debugger? It seems like everyone is terrible at writing queries. Yes. So we're trying to make so I mean I've been writing queries PromQL queries for I don't know, maybe 2 years now, and I'm struggling still. So I'm totally with you on this. We're trying also to come up with ways to do a graphical PromQL builder, but it would be heavily reduced in the functionality because the strength of PromQL is basically the vector math logic and the vector matching, and this is really hard to basically provide builders. It would be basically nested builders, and it gets really complex there quickly. But to write simple, I guess, sum and rate queries, there's a way forward there. So we just need to find some time to build one. And then another question by Matt. Does the Explore screen allow you to set units? No, it doesn't. The whole point actually of Explore is to just not have any sort of graph or formatting options, and just to keep everything to a query and to like a run button and the results. Yeah, that's the whole idea there. And a couple of people are typing, but no. Okay, I think that was it. Any more questions from the audience? No. Cool. All right. Yep, that was it then.